Welcome back, everybody. We will now start by defining the greatest common divisor, and then we will do some examples. And in the next two videos, we will be talking more about computing greatest common divisors. So what is it? A common divisor of integers a and b is an integer d such that d divides a and d divides b. That is, a common divisor of integers a and b is an integer d that divides both a and b. You can also say that d is a common factor of a and b. Now, what's the GCD? GCD is short for the greatest common divisor. The greatest common divisor of integers a and b, not both 0, is the integer d such that d is a divisor of both a and b, and if c is any common divisor of a and b, then c divides d. We use the notation for the GCD d, so we express d as GCD, and then by writing a and b in parentheses by separated by comma. Sometimes we don't even bother to write GCD, we just write ab separated by comma within parentheses. Now this notation right here is kind of misleading because sometimes we use that for denoting just points and so on, but the context, when we use this to denote the GCD, the context should make it clear that we are indeed talking about the GCD. So once again, the greatest common divisor d is such that d is a common divisor of both a and b, and d is divisible by any other common divisor of a and b. So let's say we want to find the GCD of 36 and 22. And here, notice that I use the word, I ask also, are they relatively prime? So what does that mean? Well, if the GCD of two numbers is 1, then we say that they are relatively prime. But we're gonna talk about that in a second. So how do I find the GCD of 36 and 22? So one way to do it is that we list out all the divisors of 36 and 22. So what are the divisors of 36? Well, it's 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay, and what are the divisors of 24? Well, that's 1, 2, 3, 4, 6, 8, 12, and 24. So now we look at the common divisors. So you see that 1 is a common divisor, obviously. 2, 3 is a common divisor, 4 is 1, 6 is a common divisor, 12 is a common divisor, and those are the only common divisors. And then obviously the GCD, the greatest common divisor, is 12. Now here is another way of doing this. So again, it's the same question, finding the GCD of 36 and 22, but this time I'm going to do it differently. That is, what I'm going to do is factor out 36 and 22. So if you factor out 36, what you're going to get is 2 times 2 times 3 times 3, which is 2 squared times 3 squared. And then 22 is 2 times 2 times 2 times 3, which is 2 cubed times 3. Okay, so these are the factorizations of the two numbers. And now we can see what the GCD is. Well, if you look at the, one of the common factors here are powers of 2 here. So we pick the smallest power of 2 because we want a common divisor. If we pick 2 cubed, notice that 2 cubed doesn't divide 36. But 2 squared divides both 36 and 24. So we're going to pick 2 squared, And then between 3 and 3 squared here, we're going to pick 3. We always pick the smaller power. So then we get 2 squared times 3 here, and that's 12, and that's the GCD of the two numbers. So this is another way of finding the GCD. Okay, so now like I said, if the GCD of two integers a and b is 1, then we say that they are relatively prime. So if the GCD of 0, 0 is undefined, and the GCD of a comma 0 is the absolute value of a. The reason I'm taking the absolute value of a because a could be negative, and the GCD is by definition is positive. Okay, so 8 and 15, are they relatively prime? Well, let's look at it. So 8 is 2 times 2 times 2, and 15 is 3 times 5. So notice that the factors of 15, they don't divide 8, and the factors of 8, they don't divide 15. So clearly the GCD of 8 and 15 would be 1, and they would be relatively prime. The GCD would be 1. So when the GCD of two numbers is 1, we say that they are relatively prime. What it means is that they don't have a common factor bigger than 1. So when two numbers are relatively prime, it means that they don't have a common factor or a common divisor greater than 1. Okay, so 8 and 15 are relatively prime. And so here's an exercise that you have to go over. When you find the GCD of two numbers, if you have negative integers there, you can simply ignore the negative signs. And in the next video, we will be starting to talk about the Euclidean algorithm. See you then.